Hello, ladies. I'm sorry I wasn't really adaptable to meeting early before we have to, but I think it is great for us to talk about scope and sequence of the course this year. I know there's a few things I threw out at the end of last year, particularly to maybe teaching nuclear chemistry after the basic, like before we teach electrons, between basic atomic theory and electron stuff, because I feel like that's a good way to do it in context, and it's not very long, So I that's one thing I wanted to entertain with the group, but certainly not everybody has to do it. I know we're supposed to pretty much all be on the same page, but I do have kind of a considerable change I wanted to make for this year, and it's not one that I expect everybody to make, as I mentioned, because it's kind of different. It's kind of big different. And the big different is always bearing in mind that I might have to do a project for the year. So a lot of my ideas pertain to that, and they're like big changes because of that. But I did want to share them with you anyway, in the event that it's something you might want to do or we might consider in the long term. But I'm totally cool with just kind of going rogue and being the pilot for this year and maybe reporting back. So I have sent you this file. It's the start of making sort of a plan for what I'm going to describe to you. As you can see, that I don't have the standards filled in yet, but I'm working on thorough descriptions, and I just wanted to give you sort of a base for what I was thinking when I did this. And so before I do that, I want to sort of share how it all fits. So as I go through here, I'm going to first tell you that I'm going to heavily use CK12 as a resource during my in-class time this year. CK12 is a website where you can basically make your own textbook with existing content. So what you see here is just it represents the CK12 issued chemistry textbook, which is almost Wikipedia based. Like, they have professionals populating it, but then you have community based contributions as well, and you can further customize it. I did a certification over this summer for it. I spent like 10 hours learning about the whole website, and so I am committed to using it. And I'm going to use it as an in-class tool. So I'm not going to assign reading from here, but I might, for example, spend one day on why to study chemistry, break the kids into groups, and have each group come back with a mini presentation on how is chemistry incorporated into medicine, how is chemistry incorporated into agriculture, and so forth. I can assign this resource to those students, even that particular lesson, and they can log in and do it. So the lessons that I'm writing this year are going to be heavily connected to this. So that might help describe how and why maybe some of my descriptions are as they are in that unit and lesson plan. Also, this is the site that I used last year for some of those heavy interactives, and I'm hoping for those to be also good in-class group activities as well. There's also adaptive practice that's in here that I plan to assign during practice time in class. And so this is one of my heavy pieces and can probably be a separate project in itself. The other one, again, just to provide you with context for how and why I'm making this plan that looks like it does in the Word file, is visible learning. This is something I picked up in a blog last year that I followed through with over the summer reading the book. And the book is entitled Visible Learning for Science: What Works Best to Optimize Student Learning. And I just personally think it's a great book. For me, it tied a whole bunch of things together between Bloom and DOK, and specifically what my job is that nobody ever told me. So I love it. It's really just visible learning as a principle, and then they make more money by writing a book for science. They also have a book for writing and math and whatever. But as an overview, you can see here they talk about surface, deep, and transfer learning, which is not, contrary to what it seems, it's not like vocabulary, problem solving, and extension. It's different than that. It's basically about the strategies you use to teach and the way you construct tasks, and that teaching should be very social. which is obviously very difficult to achieve in our environment. But anyway, I just wanted to give you context for maybe why this looks the way it looks. The third thing, so that's like probably my second project idea, is to evaluate visible learning in the cyber classroom. Third is spiraling the content. So and I kind of feel like that all of these three things intertwine, which is why I probably will put them all together in a project if I have to. We talked about spiraling in one of our PDs. I loved it, but didn't know how to do it. And I think chemistry is like a super class to do it in if you know the content, the material. I think there's huge potential here. And I think there's a few areas that we could really be able to measure it. Like, for example, on the Rutherford question that never gets answered properly, the periodic law question that never gets answered properly, in understanding intermolecular forces and like dissolves like, and some of those big issues that are central and fundamental, and that they should really be getting, they have to get. So it doesn't, at first I was like, this is going to involve rewriting the curriculum. It doesn't. I don't believe it does. However, probably requires an introductory unit. And so what I've come up here with is pervasive principles and a list of topics that I felt underlie the entire course if we were to deliver the entire K-12 course. And so with the idea being that each of these lessons gets reinforced in any number of lessons throughout the year. So while we're introducing them at the beginning, it's just for a baseline. And the intent is to go back to them repeatedly in the context of other lessons. So the topics I came up with include why we study chemistry in high school. Okay, and so I started there because that'll be my first lesson, and that'll be basically this: macroscopic versus microscopic. What we see versus the particles we don't. Also, every area of chemistry. And then how it applies to the world we live in, with the ultimate goal of coming out an informed citizen, being able to problem solve. And mostly just sets the tone, right, for I'm never going to be a chemist. Why am I here? Also sets the baseline, helps practice some teamwork in this sort of new classroom model that I intend to cultivate. Maybe. The scientific method as a necessary requirement to every activity I give them, requiring observation, potentially analysis. And so just to dutifully go through those basic ideas. Then we start into the specific chemistry ideas. First being, and the first, if I were to split this up, it would be into matter and energy, culminating in both matter and energy together. So physical and chemical properties being about matter. We begin referencing physical and chemical properties as soon as we say atomic number, and that's what differentiates the atoms. So good basis to first go over the difference between a physical and chemical property and refer back to that. And then once we get into the periodic table and the arrangement of the periodic table, they're arranged by physical and chemical properties. I feel it's possible that all these years when I taught that, they were like, what is a physical or chemical property? Typically I teach this in the context of the chemical reactions unit, which is far too late, in my opinion. And I don't know how many other examples this fits into, but certainly it does. Somewhere in here, I have a lesson about terminology. I feel like maybe I'm missing this. Sorry, yeah. So there's a third lesson in here after the scientific, I don't have it in the unit plan yet, sorry. After scientific method, just basic terminology, just a totally vocab day. Atom, element, compound, mixture, solution, pure substance. So because that terminology is constant and forever, that we refer back to that. So that's like a separate lesson day. And I have a duration period. I don't know how, I'm gonna caveat to the duration for now. Okay. Physical, chemical properties, followed up by mass, volume, and density. What? We don't do any mass measurements or volume measurements or density measurements in this class. However, I feel like when we get to talking about reactions, grams of this, milliliters of that, and certainly dimensional analysis where we put two units together and put a slash between them, they're clueless. So to spend a day on determining what's best measured by mass, what's best measured by volume, what's best measured by density, or actually to extract a density is my idea there. We'll provide context to the bigger picture. When I'm giving an example and saying we're using 500 milliliters of water, there's a understanding that we're measuring probably a liquid water and that we're using a specific kind of glassware to do that. Then kind of following a storyline pattern here. Well, if solids are best measured with mass and liquids are best measured with volume, let's talk about states of matter and get deeper into this macro micro idea. Okay, so maybe even here you start spiraling. So I have nothing listed in my spiraling content column right now because this is supposed to be all fundamental. Nothing really should be spiraling yet because these are the basic ideas. But you could arguably start spiraling macro micro now. You can see water as a liquid, water as a solid, but what do the particles look like, the microscopic ones? Taking away those ideas that particles move, that they collide, and that space exists between them is fundamental to not only knowing the states of matter, but once we talk about electrons jumping from one atom to another and understanding what the distance is there or how that's happening, right? Moving on then, hopefully, I'm hoping there's some bright kids in that class that are going to wonder, well, geez, if a gas has tons of space between it, what keeps solid particles together? What are the forces of attraction? And as a seriously underlying issue here, electrostatic attraction explains why we have protons and neutrons sticking together in a nucleus, why we have electrons and protons sticking together in an atom, why ionic compounds are crystals, and why it just continues going, right? How molecules interact, hydrogen bonding, all that sets it up. I'm not saying I'm going to teach the extent of this, but to introduce the idea so we keep going back to it. Okay, so that's my matter portion. And then it's really, really bugging me that we don't have an energy component in the course. And so I intend to invoke that as lessons, not really as a unit. But to start in the very beginning with basically our absolute zero lesson. What is temperature really? And how does it interact with matter? Changes in matter are a result of energy. To me, that's a central component of chemistry. And I'm sure there's a standard I'm going to be able to pull that. We don't have to teach a whole unit on it, I don't think, but certainly it's in there. And it does also affect attractive forces. So to address that, and again, something we can continually come back to with regard to even mercury being a liquid at room temperature. There's so many areas that you can pull back on these things. Followed by heat flow and phase change. So changes in temperature, everybody knows an ice cube melts when you get too hot. The basics of that. Heat always flows from warm to cold, and you can get phase changes as a result. Then wrapping up this idea of energy with physical and chemical change, which also sort of bookends the whole thing, where you start with physical and chemical properties. The fact that we teach ionization energy, and that's such a stumbling block for our students, that they don't recognize that we teach an ionization energy trend, and that the periodic table trends are according to physical and chemical changes of atoms or properties, and that ionization process is a chemical change. And so to begin being able to tell the difference between those two, following up with that on the basics of reactions and equations. What's the reactant? What's the product? So that starting as early as, I don't know, maybe the ionization energy lesson, I can write a reaction that shows chlorine, 2, diatomic, breaking down into 2 chlorines and electrons. Not not so that they understand the whole process and depiction of oxidation, but so that they can understand that every chemical change comes with a chemical reaction. And I find that to be fundamental to the course as well. Then, maybe the whole ionic bonding portion of the bonding unit changes. So you're also teaching chemical reactions with it. It's not separated. It's not chunked to this point where we're just learning. I kind of hope this goes to retention, because you're constantly going to be revisiting. And then finishing on laws of conservation. Hey, everything we just looked at, whether you go from an ice cube to a puddle, the same mass exists. Whether you go, from an ice cube to a puddle, the same energy was involved, and explore that. And so those are the lessons that I've come up with for an initial unit. And if I assign one period to each of them, I have paced out approximately till the first week in October to do anything else. So with regard to a pacing conversation, if I do this and no one else does, I'm going to be probably way behind, which is fine with me. I'm totally cool with that. Would I give a test on these things? Yes. And I would and I might not grade it, in fact, for a gradebook grade, but rather use it as a baseline for questions that I will insert on tests to measure mastery over time, just specific questions and even specific students. Now, with regard to pacing, because I intend to do things differently in this regard, with being more social and much more team-based, and me giving less and less information, making them do more and more of the work in class each day, I don't know whether to trust that these are going to take one period. What should take me till October 2nd might take me till October 20th. And this is the first time I'm going to detach myself from a pacing guide. I'm going to plan a week, but if I get behind, I get behind. And I've never approached things that way before, but I kind of feel that in spiraling this way and connecting the dots before putting all the dots on the board, that even though I'll be using more time, I'll be covering more material, is my theory. I don't know if it'll actually end up that way. I'm not done. This is totally a work in progress. In fact, this whole extra table is just for formatting purposes. And then every Wednesday, part of the reason it would take me that long is because every Wednesday I intend to give them a practice day to review and practice all of the concepts between Wednesday and Wednesday, and be able to work with them individually during that time, give them a graded assignment on that day. So that's what that's about. I know this doesn't look like our typical format for lesson plans, but I have sort of lesson plans here, individual lesson plans, and it was just brainstorming, really. I'm trying to find a page that they're all on one page. So sorry for the scrolling. Here, let me do this. Okay. And this brings in the visual learning component. I don't have the learning intentions yet. These are done really specifically according to the visible learning thing. They're not as straightforward as I used to write my goals. And they pertain to the surface or the deep or the transfer and how you're connecting things or not connecting things, and then success criteria. How am I going to know they did it? So that's what this is all about when you see this. Success artifacts. What are we going to have at the end of class to show that the class as a whole has achieved the criteria? And then what am I going to have for individual students? But the big key here being the student experience. I'm probably going to be disappointed by like October 1st, right? Because I have this super high hope that this revelation that my job is more about providing students with an experience in learning, not to teach them. And so every one of these lessons, I do have in my head an idea, and I get the idea of what they're going to do all ties back to this website right here and the resources tied up in it. But really it's to take the onus off me. and to put it on them, and to make class time about what they have gathered. And it's really going to be all observation based. It's going to be all, you know, hypothesis based, and then for me to maybe reveal at the end. So also sort of trying to design every class is a lab class where they get an answer key at the end, and hopefully maybe some light bulbs go on. It's interactive and fun. And what I've seen through this, or what I believe right now, is that in the past my lessons dutifully contained engagement, where engagement was defined as something a student had to do, anything a student had to do. So click the green check was something a student had to do, and I feel like now that's woefully inadequate for me. And again, I'll probably be crying by October 1st, but I'm gonna try my damnedest. And I've been working on this honestly since like April. So again, I have like super high hopes. Anyway, this idea of a word wall is something that came from that book. My kid uses a word wall in kindergarten and first grade, and I think it's an awesome idea to create this word wall with them, and every day, instead of presenting them with the vocab, for them to go find the vocab, and for us to make this this wall and do this thing. And so anyway, that's my plan. And so if anybody else is on board, I'm happy to exchange notes with you regarding the lessons and how I'm making them, and to see what ideas you guys have. And if you want to completely ignore me, I'm totally game for that too. But this is part of the reason why I didn't really want honors this year too. It was so difficult to even think about making changes, you know, big changes to one class while juggling two. So I feel like I have a little bit more freedom to play this year. And I don't want you to misunderstand that I'm being like the difficult team member. I just want to experiment, and ultimately I might just come back to exactly what we did, but hopefully I will have data to either support or reject some or all of this. So anyway, food for thought before whenever we do have our first meeting. I hope you guys are still enjoying what's left of your summer. Bye.